Good afternoon. Brad McConnell from Eastern Iowa Community College's Blong Technology Center campus, continuing on with our series of 3D printing videos. Today I'm going to cover just the basic fundamental operation and parts, if you will, of a Lulzbot Taz 6 Fused Filament Fabrication 3D printer. You'll notice we have a couple of different spools of material. This particular spool I just have here to kind of show you one of the mechanisms we can use to feed material. That arm sticks out, and you'll see one of the reasons that I really don't like it. It's kind of cumbersome. So I can put material on here, and I can take this material and feed it up through a plastic tube down into the hot end and print that way. I found that I have trouble with the feeding mechanism, and it gets caught in the plastic tubing sometimes. And if I'm not right here watching the print, then I may very well get a stop in the flow of material, and so the print is just aborted at that point. So what I did is I got online and found that there were a couple of designs for these particular A-frame type holders, and I had my CNC machining colleague at the college machine up a couple of aluminum rods, and so I kind of modified the design of these A-frames and printed them with a different 3D printer, and then put them on here with wire ties onto the frame of the machine. And so now I can just take the rod, put it through the reel, put it on the A-frame, and I get what I like to call a direct gravity feed, and I don't have problems, or as many problems that way, with material feeding. So that's just a little modification I made on the Lulzbot. And again, this is a Taz 6. Lulzbot makes several printers. This is kind of one of their workhorses. It's got a 12 inch in the X-axis. It's got 12 inches in the Y-axis, and roughly 10 inches in the Z-axis. So you'll see it's got a pretty big, a nice sized build envelope, and we can print some pretty big parts or many little parts in one build. You'll notice that we have the control panel over here. We can control the whole printer and the print from this control panel, or we can download Cura for Lulzbot, hook this up to a laptop or a desktop, and we can use the printer through the software and control all of the operation of the printer and the build that way as well. So you'll notice a few things about this this build plate on the Lulzbot Taz 6. The covering, this is a glass build plate, but it's got what we call a PEI surface covering. So if that gets too torn up, we can strip that off and replace it. The dressing we use, or the preparation for the build plate, is typically just your regular old glue stick. I pick these up every year before school starts in the fall. They've got really good sales on these, so I just pick up a bunch of them, and we use those. Now, some material doesn't call for any glue preparation, but typically we do prepare for PLA and for ABS, nylon, and most materials will call for a glue stick layer before you start your build. Now, this particular build on the Taz 6, or this build plate rather, is also heated. It goes up to, well, I think between 80 and 100 degrees. Therefore, we can print some pretty good material on this particular machine, because when you're using material grade or engineering grade materials, typically you'll need a higher temperature on the build plate. For PLA and ABS, we're somewhere between 40 and 60 degrees. Now, you'll also notice that I've got some disc here on the build plate. This is a self-leveling plate, which is really nice. Many of us who've done this for a while have used machines that are, we have to manually level those, and some of them still are that way. But this is this has got self-leveling. So the build head here, when it comes down, the hot end comes down And this particular disc over here on the left, that's not in the corner, that's a homing disc. And what that does is helps the printer, it helps it find its 0, 0 location or where it's going to start. Once it homes in and finds that position, then it comes and typically will clean off using this brush plate down here, will clean off its the hot end, the tip, where the material comes out, and then it will touch off on all 4 of these corners, and through the firmware will automatically level the bed depending on how far out it is. I've had really good success with that, so I'm happy with it. Now, I keep talking about the hot end. The hot end is up in here. I'm going to do another video that actually pulls this build head off of here, so we'll get a better look at it then. Now, when we look at travel on the y-axis, you'll notice that we've got some stainless rods here. We've got a little gear, and there's a bearing underneath, and it runs from a belt. So we get our Y travel that way. The X travel we get up here on these cross members, it just travels back and forth here, and you'll notice that we've got the drive belts here. Now, these 2 straight posts and then the drive screws are what gives us our motion, if you will, for the Z-axis. And that's pretty smooth, and it runs very nice. Just throw a little white lithium grease on there every now and then, and everything seems to work out very nicely. So that's pretty much the overall running of the actual machine itself. We've got some little drive motors down in here. We've got a drive motor up here to drive back and forth this way, and we've got one here in order to give us our Y travel. And those are fairly easily replaced if something happens. You'll notice I'm using a plastic pen here. You want to be very careful so you don't short circuit something out. Earlier in my ownership of this particular machine, I blew out a fuse on a circuit board that's over on this side, and it was $1 fuse, but it was still kind of a pain. So anytime you're doing any work on this, like a tip change or something, you want to make sure that the power is off, which we can do right here, and that it's unplugged. And probably very wise to do it on a static bench too, so we can make sure that we're not getting any static electricity that would pop anything off.